some some plugins. As you can see, in browse section you have 2D assets, animation, blueprints, character, plugins, and any other thing. There's also completely free, so that you can not you don't have to pay much for the assets. So let's start with launching the engine. As you can see, this is the first screen you will see. So the side you can start with the game, you can start with automated design or architecture, film, and everything. We can start with games. Now you have to choose various templates. First is blank, with no code and no assets. And you can start your template with first person shooter. It will already have a gun and hands and projectile and physics based blocks. So you can start with that. You have flying. You can also create an AR project for Android iOS devices. You can create games, you can pretty much do anything. And you have some vehicle system and some advanced vehicle system template already available. You have virtual reality. I've already created a project for this session. So, okay, so this is what the engine will look like. So we will be creating this game where the where this platform is already and you can move your character. So this here is your word outliner. It represent how what are the actors currently on the your level. Like when I simulate it, so these are the floor, as you can see. So all the objects are in that are in your level will be shown in this word outliner. You can reposition them in anywhere on your screen, like details panel here, according to your needs. So yeah. So what is happening currently in this level is, let me show you. So what is happening is the player is not moving here. It's the platform that is moving. So I made some boxes to detect the collision. When some floor get when some floor hit this box, it will get deleted after some time. And when it get deleted, a new floor will be spawned at the at the top position. So you will have like endless floor all the times. And of course you can change the speed, like make it 500. So yeah, and so minus 100. Yeah, so you can just control these things, like which actor to spawn, how many actors you want simultaneously with this. So we will be creating that from scratch now. Also, this is your content browser. I mean,
Hey Ram,
this is
um, your screen is not shared anymore.
oh sorry.
Here's good now. Thank you.
Yeah. So this is a content browser. It basically is what assets are you currently in your project. It's like a folder. So as you can see, I have some meshes like this block, and these are my logics, and there's some animations, everything here. We can import our own animation and our own assets from this import folder. So, and these are all the actors that are available to ready to drop on level. Basic stuff like cubes, sphere, and some cameras and some visual stuff like clouds and this. So we will start with new level. So this will be our level, our sample level. We can, it's currently positioned at origin 000, and this is scale. So we can, let me just show you. We can make it bigger, like 100. So the controls to navigate on this keyboard are just the same for game, like WSD and mouse. And we can, yeah, we can just drop anything here, like I drop this cube here, or I drop this character here, like here, and you can see that it's in word outline and this character and this cube. Uh, to simulate the physics on any object, it's simple as that. You just click on simulate physics, and this block will have physics. And there's many other properties like dampening. You can also enable gravity. If you want to simulate physics and you don't want gravity, you can do that. So now you block will not have gravity, it will just free floating. So these are just the basic. So now we are creating our game. So we will have to create a new folder from our tool. And I will create uh, so I will create a new blueprint class. So what is blueprint is we can create anything like a pawn and character. It's just a code. Like you can either create a C++ code, a class file, or you can create a blueprint file. So in this lecture, I'm going to show you the blueprint file. So we are going to create an actor. So this is a blueprint file, and here we can create our very own logic. We have this begin play method, and this is eventing. So begin play is what when clicking the play button, it will call the first. It will call first, and this event tick is what it will call every frame in the game. Like if you have 60 frame per second, so it will call 60 in a second. So this is used in like animating things and moving things. So we'll be using that, and this is our panel where currently that this actor has nothing. So we'll be adding it a static mesh. Static mesh is just an object, and we are adding a template for. As you can see, this floor is added here. Now we can drag this thing and just like our regular floor. But now we have the ability to add a logic on this mesh, because we are creating a lot of them, and attached like this, and it will be moving. So we need to add this. Let me just delete it. So now that we can drag it here and drop it. Uh, for this game, for this level, we need to actually spawn this dynamically. So we need to create a uh, spawner which is spawn this floor and how many floor and what speed that it will be spawned. So this we are creating the spawner. We can name it any like spawner base. So in the event graph, which is what I just told, that you can add any logic. So we are now spawning our floor. So I'm going to create a spawn function, spawn actor, just a function like in our code. So what it will do, we are going to spawn objects. So we have a class like spawn actor from a class. So we will just give the class name, which class. So what we just created is this floor. We can choose floor here. This is a execution pin which shows that you are heading from this to this. So we are calling this already made function in the engine, which is spawn any classes that you write are already available. So we are creating this. We have already created this floor, and I'm going to spawn it now with this function. The transform is what its location, rotation, and scaling. It's this. This is what the transform is. What will be its location? What will be its rotation? And what will be its scaling? So we can split this pin into three. So we can now add, and this function will currently return nothing. So we can add a return node to just do nothing. Okay. So this will be the simple function which just spawn this thing. And now we can create a child blueprint class which inherit from this. And what we can do now is in the begin play, we can call the spawn actor function that we just created in the parent class. Now if we drag this and click simulate, as you can see our floor is already been created dynamically with this spawner. Okay, so yeah, that's it. So the this blueprint class spawner based child is at 0, 0 position, and we have not specified any position to spawn. Where is so it's spawn exactly the position that it's that this blueprint is available. Now we're creating multiple floor which just be next to each other. So for that, we'll be changing. We will be add something to this floor. So the first thing is that this floor origin is first thing we will adding is an arrow component. because we don't know the position of this and this where we'll be attaching. Like we are attaching another flow here. So I'm going to yeah. So what I just did is I attached a arrow component to it, and its location I marked the flow station here. Now I have access to uh, this arrow, and I will query while I spawning this. This will return me this floor, and now I'll be querying that what will be its arrow location, and then what will I do is I will spawn another floor with the uh, with its new location to be that, so it will be spawn. Okay.
So the arrow object, it's like an helper
Yeah,
object,
it
or it,
just it will not do anything. It just to show that as we are currently attaching another floor here, so we
Mhm.
need to have its coordinate inward position this way.
Right.
So that's why we, yeah.
Okay.
So now we yeah, this is the base class. So we will be adding two variables here, like which actor to uh, spawn. So I can name it like actor to spawn, and these are just variables. So you have all the variables here, like boolean, integer, float. So currently we are not we are be spawning we will be spawning this floor. So I will be searching for this floor, and we need to add another variable, which is actor count, or how many actor we will be uh, uh, spawning. So this will be actor count, and it is the integer. So we already have two integer. Now we will have these variable available to our child classes. So we are not going to spawn one, but multiple. So what we can do is create a for loop, and it will run from 0 to actor count. So this is get actor count, and currently the actor count value is 0, but what we will do it we will make it to public and open to editor, so that when we will dragging it, we have this actor count available in detail panel. So we will be changing while creating a level, like we need a 10 actor, or we will be needing 5 actor, how many actors. So let's just set it to 10, and now this loop will run from 0 to 10. So yeah, so for the first and in first index, so I will be comparing it with 0, and I will be searching from branch. So it's like a if condition, like if the index is 0, and if this true, and this is execution pin, It just denote where to go from begin free to this loop and from this to this. So for the first index, we will be spawning our floor, first floor, which is can spawn, yeah, here. And when we will be spawning it, we okay, yeah. So this function is just like this, where this is simple. We just created at any other origin, but we have not written our object, the floor we just respond. So we can just drag this return value and add it to return mode, and we will have available here as a return value. So for the first index where we spawn our first tile, first floor, we have now the object reference of our floor. We can promote this to a variable, which is our last floor, and we will be adding its actor location. So we can search set actor location, and what will be its location. We can choose our this spawner based child class location to this spawned actor. So uh, wherever it is on the level, whichever coordinate it is in, the location will be the same. So we can call same thing like this, get actor location, and this is just a vector. So vector color is like yellow here, and just XYZ coordinate. So as you can see, the target itself, this denote that this class location will be used for the very first tile. And now what we'll do, this is for the first index, and for the rest of the index, it will be forwarded toward the last tile. So for this, if this is false, that means it's not the first tile, but other tile. We will spawn again our actor, and with our actor, we will be set. We need to set it location. We can set it to the same location, else it will be talk to each other. We need to set it forward to uh, the location of the very first tile. So we can set actor transform. This is same as this, but we have more like what will be location, rotation, and scale here. So scale will be the same for every other floor, and location will be changed now. But we need to find the location where to spawn. So what we can do, we have the last floor that we just created, which will be the first. We can get the last floor. Now we need somehow the location of the this arrow component that we just created here, this slide one. So we need to create another function which will just return the location of the arrow. So we can call it get dash anchor, and we can write this. We can get its word location or word transform. So location will just give you location, and this will just give you rotation, but transform will give you all three. So we can use this if we want any other things to use later on. And for this function, we can add a return node, as we will be returning this transform. So now calling this function will just return this. So now the floor is just this floor, last floor. So we have that function available, which is get attach anchor. And we can we can change this location with that. Now it's very straightforward, as we are spawning an actor. We are getting the first, the last floor that already spawned. We're getting it attached anchor and its location, and we set the location of that anchor to our this actor that's spawned. And now the actor that just spawned, we can set our last floor to the actor that we just spawned. So this variable just keep track of the last floor, and now we don't have to worry about how many actors to find. It will just stack on each other. So now we can just simulate it. As you can see, we have 1 2 3 4 5 6 floor here, and we have set it 10 by 6. Yeah, okay. So as you can see, two floors are overlapping actually. And why it's overlapping is because uh, the origin of that floor is middle. So when we are setting another floor, like second floor, wherever the second floor is, it will stack its origin to that attach anchor. That's why two floor is overlapping right now. So we need to fix our floor to that. So we can move this floor. This is our origin, word origin, this actor origin, and we are moving our mesh to that varies. Now what it will do, we will have now 10, because uh, now the pivot point is very bottom, so all the actors are just stacked like this. We can change this value to 100, and it will spawn 100 floor. So now we need to add more logic to this floor, because what we can do is we need to move this floor time to time, all the floor at our direction, so that it will look like we are moving in the game. So we need to create that logic. So for this, what we can do is we can create a class that will be responsible to move any other actor or class that already created. So we can create an blueprint class. This time we will not be creating an actor, but an actor component. So it is just a reusable component that can be added to any actor. So it's just a logic that can be reused to all other actors. So I will name this BP moving. Yeah, and we have to keep moving our floor. So we can do it on the begin place because it will just call at the first time. We now need to use this eventing, which will be called at each frame for all the uh, for all for all of the game. It will give you the delta second, how many seconds like needed. So what you can do is, let me show you by printing something here. Hello. And we will be attaching this moving component to this floor. BP move. Now if I run my game, as you can see, hello hello is printing for each frame. So the component is working. Now we need to add a logic to move this floor. So yeah, so we can call the get owner. I think I need to restart my game. Yeah, so we have a method here called get owner. What this does, it will return you the owner who is implementing this component. So for our case, floor is implementing this. It will return this floor. So what we can do now, we can add a local offset. This will just add some offset of its position. So we are changing its location for all the frame. So this here. So what we first need is its current location of the floor. So current location, uh, only we will be moving our floor to x direction. So we will be needing our forward vector, which is the x, that forward vector. So as you can see, this will just return you the x vector, length one from this actor in word space. So we need to multiply this x value to a certain integer, which will be our speed. Call it moving speed. And for the value, we can give it to minus 500. So it will be moving toward us. And now that it's multiplied, we need to add this location to delta location. This is just offset. So our as it's we are already multiplying the x-axis, so our y and z are the same. Only the x-axis is changed for each frame. Now, if we move to simulate our zone, wrong one. Yeah. So now you can see our floor is moving. So because every floor is moving at a certain speed, so it will be in sync. The floor are moving. You can see uh, any floor that x direction is moving minus 500 at each frame. So it's changing. Now we have to create a, recycler which recycle this floor, as we don't want to keep adding new floor, and because it will choke our game, so we need at least 10 floor at a time, and it will just recreate itself. So for this we can edit our spawner, and we can create an collision box. So this will be just a box which just let you detect which actor overlapped it, which actor it hit, and which actor end overlapping it. So we are setting its locations, and also we need to change its size as in the level, not in this class. So we can do, we can add a variable for this. So we create our boxes, and so as you can see, this is box extend, which we can use to resize it. So we can call it here set box extend, and our box extend will be a variable which will be initial at that. Um, yeah, so it's not visible in the game. So there's a setting this hidden in the game. Yeah, so now it's visible. So we will have, so create this variable public, and we can now change it in our level. So this will help us to detect which wall just cross it. Now we need to add a logic. So in the event graph, we can click our boxes, and we override our method on component overlap, or any, we can use even on component hit. So let's just use this begin overlap. So the other actor that it returns is what actor that just hit this wall. So we will have this actor, we can cast this actor to our floor, because the floor is moving, so we can easily cast it. If fail, nothing will happen, and if it's successfully cast, then we can move our logic further. So for this we need to create a logic to in the floor itself to destroy um, this class. So we can create another custom event. It will be just destroy floor tile, and what it will do is just call destroy. So on calling this function for this object, it will destroy itself. We can add a delay of like 2 seconds, so that it will be destroyed after 2 seconds. We can now call this destroy actor. So now if we simulate our game, yeah, after 2 seconds, as you can see, it's going too fast. Speed here -100. So after 2 seconds, our first tile is not deleted, but every other tile is deleted. So the thing is working, not for the first tile. Yeah. So now after destroying, we need to create another floor at the top of the last tile that we just created. We have already the last floor available here. So we can now, after destroying, we can spawn another tile by calling spawn actor and set this actor location. And we will be calling yeah, attach arrow location. So it attach anchor and we can split this pin and that's location. And after spawning this tile, we can just uh, set the last floor to this. Now flashing infinite loop detector is that. Spawning in after attaching it and setting our last
Do we really need to spawn a new tile after a tile is destroyed? Because spawning new tiles we have already handled in that floor, right?
Yeah, we are calling the same function. We can spawn another tile, or we can just reposition our current tile to the last tile. But I think this is something happening with the delay. Uh, we can do this another way. I think it's this problem is will be the cast. So what we can do, we can create another thing for this workaround. We have a interface also. We can use that. This interface will be just for get floor tile. It will not be any input and output. We can uh, add this interface to our floor. And now we what we can do, let's rename this destroying the tile. Destroy the tile, and on destroy it, yeah, we can we can implement this event. And yeah, so what we can do now is we don't need casting anymore. What we can do is whichever actor that just that just hits, we can we have a method like does implement interface. So what and the interface will be so this will return that the actor that overlap these bounds, these collision bounds, implement this interface. This will be, I think, better than casting, as it's just checking that the actor has interface or not. And if it does implement it, uh, we can call the function of destroy flow tile. So whoever implementing this function uh, will this will be called that question wait. Let me change this to 10. You can see better. After no question. Okay, now nothing is working. Not even destroying itself. Okay, I put the wrong interface here. That's a new interface.
Okay, did it just crash?
Yeah, it's crashed for something infinite loop because it detects some infinite loop. Hmm, overlapping नहीं हो रहा spawning after
So probably in the interest of the time, we can have a look at the implementation in the existing game
हाँ yeah
and come back to
yeah
this
that
later.
will be better.
Yeah.
Yeah, so we have this. As you can see, these are the same that we just created. It's just that we cannot make it working. This one, so it's deleting and positioning another. So let me show you how it's made here. So we have a floor spawner. So this does the same thing that we just did. It checks for the implementation of the interface. It will call the desired floor, and floor here is floor here is this. We have a new mesh for this floor, and also we spawned some blockers here, which change its position to all the three lanes. And this is just the clearer function. And after destroying itself, it creates a new actor and change its position to the already created last floor and set its value to the last floor to the new tile that just created. Now for another next part is how we can create these obstacles. So in the most runner game, there are players that can only move on three lanes or four lanes, like lane to lane. As one lane is here and next one is here and other one is on right. So we have created three arrow component to detect our lane. Uh, First is left and middle and right. So we will be using this position. We will be using this arrow to get the Y position, so that next time we will creating our character, which will be shifting its position to the Y value of these left, middle, and right. And similarly, by using these anchor, we have created the obstacles. The obstacle is just nothing. It's just uh, it calls a function which get the random point from all these lane. So we are from the last zero to last index, and we are getting a random integer, and we're getting the first value. This will return the transform of these arrow component randomly. Sometimes it will return middle, other time it will be red and right. We have created this function here, like arrow component, and then we get its relative transform. We make an array and set this variable array. And then what will we did? We check, yeah. So this time for the blocker, we have not put the spawn actor from our class method, which is spawning, which is spawning the actor, because if we use that function here, what will we do that if the floor is get deleted, the spawn actor are independent to this floor, so that will be not deleted because we are actually deleting only the floor. So all the blockers will just float in the air. So that's why we are not spawning it. We are attaching it to this. Yeah, so it will just do the same thing that the spawner does, but it will attach this child to this. blueprint class, so that when this floor get deleted, the spawner get deleted also. And in the constructor script, uh, we get the random boolean value which just return true or false randomly. If it returns true, we are spawning one blocker. If we are returning false, we are spawning two blocker on each end. So this will just so so that will just spawn. We can see sometime it spawn one at one lane and sometimes spawn two times on a floor like this. And there are two blockers, and one lane will be always be free for the character to move around. So this is how the blocker is set here, and the blocker is nothing, is just a static mesh, and we haven't added any logic here because we are not making it move or anything. So we have just created an collision component, like if this mesh get hits, then we are casting our pawn means character and calling our death function. So okay, so just now we can look into our character, which is this. So this character is just made up of skeleton mesh. So the skeleton mesh is different from the static mesh, as a static mesh is just an static object which we cannot animate. The skeleton mesh is a static mesh which has a bone that you can animate. This is animation term. So this is our mesh. We have a bone for antenna. We have an eyes for this character. We can preview. We can apply animation like jump animation, land animation, or run animation at a time. So we are using skeleton mesh for this pawn. Then what we added is we added a spring arm and a camera component, so that we can make this camera active for viewport. And we have added the capsule component. This is just a collision block so that it will collide with our blocker. And for the movement, we are simply just getting our first floor and get its three lane and position and set our three variable left, right, and middle, so that we will know what the floor y value and right and middle y value is. Then it does some input. So this input can be accessed like here, like can say keyboard and you have all the keys. But we have made our custom input, which is left and right, and this input binding is uh, this input is binding here. Here. So as you can see, for the we have action jumping, which is jump. So space bar for jump and right from D, and for the left, for the left, it's right and A. We are so to move our character, we have created an enum, which is just a lane. We name it as a lane, and what it have is just three state: middle lane, left lane, and right lane. So we are just repositioning our character to, and we already have the location of each lane like this here. So if we like to in a middle lane, we can only go to left when we are clicking this left event. So we're just getting the left value and set actor location. And similarly, we are changing that. And when we are changing this position, we will be setting our enum to the new state. So this way we are actually just creating our character movement, and when we click left, we are playing an animation. That's why it just shrink a little bit, and all the time we playing this running animation. This is how our player looks like is running, and for the input, we are changing this in a value. So this is done for the character, and yeah. Also, yeah, one thing, yeah. So this is our pawn. It's just a low level character in our hierarchy. The other advanced is a character which just a child class of this pawn. So it has some other component which have ability to walk around, swim, jumping, and all the physics related stuff. For this game, we are using pawn because we don't need anything extra because we're not dealing with gravity and any other stuff. So we are creating the pawn. But the character, you can access the character here. You can add you can create your own character. You can start with very basic feature like third person template, and you can add it to product. So you will have this sample character which will have a skeleton mesh. So now this skeleton mesh is for the human. So we have all the moon like hand, and it's all the finger, index finger, middle finger. It has all the spines, and of course we can preview our animation. We can apply animation tools like run, jump, like walk. So and this is what differs from pawn to actor. Like pawn does not have any character movement component, but the character has. So this component is just like the component that we created for the moving platform, but this has all the things for a character could have like gravity scale, how much gravity applies to this character, what is the acceleration, braking friction, walking height, step height, jumping, and all the stuffs. And this is also have a collision component to detect the collision, and a camera component. And inputs are just like that we have already created. So this is our character, and to animate this, we will not be using any just random. We have created a blueprint. It uses a blueprint. What this blueprint does, it has separate logic for all the state that player have, like state machine for all, and playing animation based on the states. This is all for a character. And we can wrap this up now.
Okay. Um, Thank you, Ram. I think that was really interesting. Really interesting to see how we can create games by not writing any code at all. Like
Yeah,
all the code is just there to drag and drop.
yeah, yeah. And compilation
And
is very fast also. That in
yes,
Blueprint you don't see any compilation.
right,
You have all the method available. So it's
right,
best to just create protocol.
right. So the floor is now open for questions. If you have any questions, then you can just ask away.
Does it allow us to generate Android and Xcode projects?
Yeah, yeah. I just forgot to show you. So like we have created our game. So what we can do is we can go to project setting, and as you can see we have maps and mode. So what this does is
Um,
what
your screen
what
is not
map.
changing, Ram.
Okay, so you have a map. You can set your game map here, like what map will be open when you start this editor, and what map it will open first when the game is running. So you can set your map here, and I already shows you the input, and now you can access to all the platform. So for the Android, you need to set up your SDK and accept all the license. Here you have an option like to change your package name, and any other, like what will be the minimum SDK and maximum SDK, and your OBB file, force your OBB file to small, allow large, and all the other stuff. Also, you have for this game we have set our viewport to portrait, so that the game will run in portrait mode, and yeah. So we can also create an AAB file, bundle file, and we have a support for to generate which CPU architecture we need, and we can support currently we are checking the OpenGL, can support Vulkan if needed, and this is all for the extra tag in the manifest file, and pretty much all the things here for all the Android setting, icons, splash screens, and here you have Android SDK. I have marked the location of SDK. NDK is needed for if you are using C++ or maybe some plugin file, and Java is needed for compilation, and so these are similarly similar settings are available for the iOS and Linux, Mac, and Windows. So when you set this up, you can either launch it here directly to your mobile or emulator. Currently, nothing is connected, but you can just do this. Or also, you can package your build to share, like file and package product to Android. Now you have four types here. These are the texture compression thing. So most of the new phone use this ASTC, and all the phones older than use this, but you have also option for multi. So whichever devices use any other texture format, your app will have access to it, so you can generate it. Similarly, you can create it for iOS, Linux, and any other. So you will just create it and choose the folder, and it will start compiling. You can see in the output log it is building texture, and it will show all the error if you have, and warning. Then it start doing your.
Okay, so while it's packaging, we have another question from Anupam. Like, what are other forms of games that we can create using this engine?
Um, um, Another form means what
Um,
other types of game?
yeah, I think so.
Yeah, so we can create any type of game. So this is just a simple mobile, like I showed you the character, and we can create our beautiful scenes, landscape, mountain, and any other environment. So we can create all the games. I have show you that we have also create an AR project or VR project for virtual reality. So
Right.
that can also be done in this engine. So, and architecture, film, virtual production, live virtual production. So pretty much everything. They are very already popular game like Fortnite, PUBG. You can see it's run very well on mobile, and it's actually game changing in the gaming mobile gaming area, because previously we just have a very small type of game. Now we have just open world games. So that PUBG is also created in this engine.
Right. Nice.
Um, so I have a question. Um,
Yes.
so, so like we know there is like also a Unity. So like, are there any advantages of using Unreal over Unity?
Yeah, so Unity is also very popular, but Unity is mostly it can be used to make a PC game also. But Unreal is quite very popular. It has now have many new technologies to it broke. It now supports 2D game also, and both are better actually. Both have pros and cons. But this Unreal Engine is mostly used in high end PCs type of game, because the environment that you can create here is much more realistic that Unity. Unity is mostly used for indie people, independent, and it is used for like mostly used in mobile, but lots of game also created using Unity. So we can create a PC game too, but the Unreal is mostly been used for the PC development.
So you mean where the graphics they're like more kind of real, near to real term
Yeah,
thing,
yeah, yeah, yeah.
real
So
physics or
yeah, both achieve photorealistic realism, but recently Unreal Engine shows a new concept, and it has new technology that is far from very. It's very unreal type of environment that you can now create. It has its own, and also it has a very bigger tool, like the blueprint tool that I just showed. It has a great artificial intelligence tool here. You can access like behavior tree and any other stuffs, and yeah, pretty much everything can do it.
in terms of physics, is there anything it's like in terms of like you mentioned about the
Yeah,
graphic real.
yeah. There is this thing. It's called chaos. It's a chaos. Yeah. So that is very cool. It is, I guess, to yeah. So this is you don't see most game where you can just destroy anything at all. But in this chaos physics, you have very beautiful type of this physics where you can destroy any part of your world, like meshes, landscape, and etc. And
Okay.
there's many so many things here.
I'm sure like both the platforms have their differences.
Yeah,
So from what I understand, like Unreal is more capable in terms of
yeah, PC
like
games.
photorealistic graphics,
Yeah, yeah,
and Unity is more for like less graphic intensive games for now.
yeah. You can
If I'm
create,
correct.
but it's easier in Unreal Engine, because they just showed you this demo. There's so many demos. This is real time VFX. It's now used in many film technology. So before we have a green screen and then some post production to create a set like this, but now it's just in the real time. So as you can see, everything can be changed real time from setting to escape. So
Okay. 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 So it's the same technology with which Mandalorian is being showed, right? The Star Wars season. Like there, they don't have
yeah,
green
yeah,
screen either. Yeah.
yeah,
Okay.
yeah. So also the Star Wars game is also made in this engine, And nowadays this engine is very picking up. The film study industry is using this engine a lot, as this is I guess launched 2 years ago, and this is very groundbreaking system.
Mm.
You can use it on weather forecasts like news and any other things, and it's just real time, so you don't need to spend on post production. It will just change your words dynamically on real time.
Cool. Um, do we have any other question?
No question as such. Was just want to thank you for sharing the stuff. It's quite interesting. Thank you, Ram.
No,
Thanks,
thank you.
Varun. Okay, so we have another question from Anupam. Have you published any game using the Unreal Engine?
No, currently I'm just playing around it. I guess I started. I usually play a lot of games in my career, but since the pandemic, I started doing something new. So I started using this engine on 2020 as a New Year resolution. So it's been, I guess, just 2 years since I played around it. I made many samples. I've created some word, but haven't published a full game because publishing a full game requires a lot much more.
Yeah, it's a humongous task. There are so much
Yeah,
to publish about.
and
Like,
you can lose motivation during the project, after the project.
yeah.
Publishing anything is very hard actually, not just a game by
Right.
yourself. If nobody is um,
So Ram has
trying.
interest in particular horror games, and he has
Yeah,
created some really cool demos.
yeah.
As you
Like
can see
I
in
can
the
show you
video.
my work. This is my channel. So this is I am learning cinematics a few months before. So here I have created some cinematics where a car scene, and I have switched the shots here. Then I move some reindeer, and this is very funny. But I have polished it somehow, and we show you the final. This is final. So I changed the lightning. Yeah. So I created this widget also. So to make an UI, it's also very simple. No code is required. It's just a drag and drop of text, and then like we have in Android, a toolbox. So yeah. So as you can see, now we have lights and street lights and lamp, and also the deer is now running smoothly and it and the camera shake. This is I created few months ago.
Okay. Can you also explain, Ram, like how it is, like what things are working, like what you have to do to make this a little
Uh,
Uh,
high level quick overview might help.
I think
yeah.
we are
So
out of time, Shivansh. Probably you guys
yeah,
can
because
connect offline
Yeah.
and take this further.
so this
Um,
so I've created this like June, I guess. Then I stopped working on this, losing my motivation. I'm currently learning some little bit about modeling, as during game development you often need that something that you downloaded is not syncing with the area, and some custom animation that you want, you can find it on the internet. So that's why before I'm trying to launch my game, I think uh, I'm starting to some character rigging, character modeling. And then I think I will put all together to make a small final game.
Cool. Okay, guys. So, like we are out of time for this particular talk, and although Ram has like explained all the parts of the game that we wanted to cover in part two, but if there is like enough interest in the part two, then we can do another part of the same talk where we can go and create some more sophisticated landscapes that Ram showed at
Yeah,
the end. So
we
let
can
us know.
create this landscape that we just created. I can show you the night scene and day scene, and some cool landscape design like grasses, trees, and lakes. And if you want the part two of this endless runner, we can create pickups for coins like power up like magnet, and we can also make a touch screen helper to detect left and right swipe, and then really publishing and really creating an APK out of it in the next part.
Right. So let us know your feedback on Slack or emails or meetup, wherever is convenient for you. And thanks for joining today. Thanks, guys.
Thank you. Bye.
Bye.
Thanks.
Bye.
Thanks.